Page 379, Chapter 18, Part 2. Failure Mode and Effect Analysis. FMEA, Failure Mode and Effect Analysis, has its origins in the military and industrial fields and is a method of identifying and preventing problems with products and process before they occur. The FMEA process seeks to accomplish several things. First, it aims to define the topic that must be addressed, for example, replacing a hospital boiler. Then assemble a group of multidisciplinary staff to identify possible hazards and causes. Poor steam quality, pipe ruptures, and service disruption. Finally, the team identifies actions and outcomes for each potential problem. For example, before replacing the boiler, it may be important to rent a temporary steam generator to use if possible and if problems arise. So, the food service department, OR, or CS, central sterile, may remain functional if any of the identified problems occur. Definitions: Failure Mode and Effect Analysis, FMEA. A process designed to predict the adverse outcomes of various human and machine failures to prevent future adverse outcomes. Root Cause Analysis, or RCA. A process that looks backward at an event to help prevent its future occurrence. Root Cause Analysis. Root cause analysis, or RCA, is a reactive process that uses historical analysis of an adverse outcome to help prevent its reoccurrence. Assume a washer disinfector pump malfunctioned and caused instruments to be improperly cleaned. Each event after the pump failure would be examined to determine what could have occurred and what can be done to prevent this issue in the future. Another example is the tip of a carbide insert on a needle holder breaking during surgery. All members involved with the set will meet to determine what happened and how to prevent this from happening again. Members of this meeting should be the surgeon. How was the instrument used? The scrub technician and circulating nurse. What happened? Was the instrument checked before giving it to the surgeon? The CS manager and the technician who assembled the tray. What are the set policies and procedures for instrument assembly and testing? Was the instrument properly checked? Risk manager usually serves as the meeting facilitator. And any other interested parties, such as instrument repair technician or infection prevention personnel. This group will determine what went wrong at each step of the process and determine how to prevent the problem from happening again. RCA is widely utilized in the medical field to examine contributing factors to adverse events. Note, the Joint Commission, TJC, Standard LD 5.2 requires facilities to conduct root cause analysis on any sentinel event that is reoccurring. Definition: sentinel event. An unexpected occurrence involving death, serious physical or psychological injury, or the risk thereof. Quality program alternatives. Many CS departments utilize a quality assurance program because it is comprehensive and requires the gathering of data to ensure that the quality product is regularly produced. The number of items not meeting quality requirements is compared to the total number of items produced. There are many quality assurance programs utilized within the healthcare industry. Some of the most popular are Total Quality Improvement, or TQI. Involves measuring the current output of process or procedure and then modifying it to increase the output, increase efficiency, and or increase effectiveness. TQI recognizes that improvement can occur with an individual, a team, an organizational unit, such as the CS department or the organization staff. Continuous quality improvement, CQI, is a statistical method to improve work process. Planning and implementing a CQI program for instrument processing involves the receipt and use of input from the decontamination staff, processing employees, clinicians, and physician personnel, and all others involved in equipment use. This team can assist in identifying where more training is needed, multiple users, where process changes are needed, multiple departments, and what the expected quality outcome should be. Total quality management, TQM, is an organization-wide quality approach based on participation of all members. The aim is long-term success through customer satisfaction and benefit to all members of the organization and society. TQM requires that the facility maintain its quality standards in all aspects of its business. It also ensures work tasks are performed correctly the first time and that the operational defects and waste are eliminated. The above are just a few of the formal quality programs used in healthcare. Many facilities develop their own quality program utilizing a combination of several of the above programs. As long as the program works for the facility and emphasizes the main focus of quality patient care, it doesn't matter which program or combination of programs are used. Figure 8.7 provides an example of quality report that identifies the types of instruments and errors. Figure 8.8 provides an example of a report indicating progress and efforts to reduce IUSS, immediate use steam sterilization. Definitions. Quality assurance, a comprehensive and measured effort to provide total quality. Also, a technical statistical sampling method that measures production quality. Total quality improvement, TQI, the concept of measuring the current output of a process or procedure and then modifying it to increase the output, increase efficiency, and or increase effectiveness. Continuous quality improvement, CQI, a scientific approach that applies statistical methods to improve work progress. And finally, total quality management, TQM, a quality management approach based on participation of all members aimed at long-term success through customer satisfaction and benefits to all members of the organization and society. Six Sigma and Lean Six Sigma. In recent years, healthcare facilities have begun adding Six Sigma and Lean Six Sigma programs to their existing quality programs. Six Sigma. The objective of Six Sigma is to deliver high performance, reliability, and value to the end customer. It is a highly disciplined and complex process that focuses on developing and delivering near perfect products and services in an ongoing quality effort. This process strives to eliminate variations in a product. A tray will look the same each and every time it is assembled and will look like the same product produced before it. This eliminating variations to prevent defects. It focuses on process improvement and variation reduction by the use of Six Sigma improvement projects. Two of the process that most use in Six Sigma are DMADV, which is define, measure, analyze, design, and verify. A process is used to develop new process. Or DMAIC, define, measure, analyze, improve, and control. Procedures monitor and improve existing process. Lean. Lean is a production practice with the key tenet of preserving value with less work, eliminating waste. Eliminating wasteful process reduces production time, and costs. Lean's strength is at its fast implementation. Let me repeat that. Lean's strength is its fast implementation. Immediate benefits relate to productivity, error reduction, and customer lead times. Long-term benefits include improvements to financial performance, customer satisfaction, and staff morale. Both Six Sigma and Lean focus on refining the process while reducing defects to an extremely low rate, less than 3 to 4 errors per 1 million products produced. Definitions. Six Sigma, a quality process that focuses on developing and delivering near perfect products and services. Lean, a quality process that focuses on eliminating waste in the production products. In figure 18.9 on the bottom of page 383, it provides a comparison of Lean and Six Sigma process. I'm going to read this chart to you, 18.9. Lean is on the left, Six Sigma is on the right. I'll be reading left to right to compare both. Lean, map out the process. In the case of instrument assembly, each step the instruments take from use to reuse is documented. Six Sigma, map out the process. In the case of instrument assembly, each step the instruments take from use to reuse is documented. Lean, refine the process. Identify what steps in the mapped process are not necessary. Six Sigma, identify the defects. Where are the mistakes happening? Lean, developing the new process based on the information identified during the refining process. Six Sigma, what is causing these mistakes? Correct the actions that are causing the mistakes. Lean, try the new process. Six Sigma, try the new process. Lean, gather, analyze, and document data. Six Sigma, gather, analyze, and document data. Lean, adjust and refine the process as necessary. Six Sigma, adjust and refine the process as necessary. Finally, monitor. Lean, monitor and report data. Same with Six Sigma, monitor and report data. End of chapter 18, part 2.